We're going to start in just 2 minutes. Let everybody, a couple folks are running late, and I want to get everybody started at the same time. Hello, everybody.
Hello.
How you doing?
Good. How are you? Everybody having a
Doing
great
all
day?
right.
We're gonna see some people coming in a little bit late. Guys, it's gonna happen with this random change that we did, but I think it's better for everybody so that you East Coast people aren't staying up until 11:30 listening to me talk. That was a little bit unfair. Yeah, like next week's train that starts at like 2:30. So that I try to make it fair. This was a little bit unfair for you guys. I apologize. But yeah, let's start back with questions that we had from yesterday. Anything you guys needed help with, stuff like that before we get started on everything else. That way, if a couple folks, they pile in, they pile in. No questions from yesterday. Everybody's pretty solid. Fantastic. Cool. So we're gonna go into this. Make sure you guys have your pens and papers and get all that stuff started and ready to rock and roll. I am on my 6th Red Bull for the day, so this is gonna be a fun training for you guys.
One more higher than I am right now.
Cool. So, hey guys, again, I'm gonna preface this entire training. You will not understand like 90% of it. You will forget like 90% of this. It is okay. 100% okay. There are going to be some mathematical algorithms and formulas that I'm going to be showing you guys today. That's for you guys to know that this is the type of stuff we do on the back end, so that you can say, look, these guys do a lot to make sure that your data is correct. Your system is built correctly. Okay. And some of you guys might actually like the information, and it's good for you to know. So if you're sitting down with an engineer, eventually one of these days you're like, okay, cool. P times I equals V and all this other stuff. So you guys are going to see all that. It's going to make sense eventually. Today, at the end of the training, you will feel a little overwhelmed. You will feel as if like, I don't know how I'm ever going to remember this stuff. The way that I put the training together is definitions. Okay. So certification starts. We are going to be going over definitions first. So the definitions are how we actually, it's going to be the word and then all the stuff that piles inside of it. What happens after the fact is we put those definitions to the proposal on Thursday and Friday. Everybody always tells me, Just remember, stick it out. Don't worry. You're not dumb. It's going to be a lot of information. Everybody tells me it's like, oh, all that stuff from Monday clicked or from Tuesday clicked in my head. Like once you started explaining this stuff, it's going to be said a lot. We're going to repeat it a lot. A lot of the stuff, the actual certification itself on the test, on the questions, is going to be an overview of what you guys learned here today. It's going to be like a mile high. It's not going to be specific with like, how do you calculate the azimuth and how do you do these numbers and how do you do this formula? It's not what you guys are going to be tested on. Okay. It'll be like overview stuff. But like I promised, Solar Panel Pro, this is the shirt that I was telling you guys about. It's my all-time favorite. We're bringing it back. We're bringing it back. Okay, cool. Let's get to it. Solar and electricity. Okay, so guess what? They are interchangeable. Like we need one in order to have the other, and sun creates energy and all this other stuff. But you need to learn about the actual electricity portion of it itself in order to be able to properly, I'll explain some of this other stuff. So what is electricity? So when you guys get your electric bill, it's listed in usage in kilowatt hours on your utility bill, right? So kWh. But when you go to the store, you see things like 12-watt light bulbs, 9-volt batteries, and vacuum cleaners with 15 amps of sucking power. What do these numbers mean? Right? This is what we're going to be going over today. Well, the reason why all this stuff is different when we're looking at power is because we're trying to create a circuit. And there's several things that need to happen in a circuit for electricity to flow through to get the work done. So we're going to think of it like a faucet, okay? So think of the circuit kind of like the faucet in your kitchen sink. If you want water to come out, you got to do a couple things to get the water out itself, right? You need some pressure to force it through the pipes straight out of your faucet. An electrical circuit uses electrons to carry the electricity, kind of like the water in your faucet, but those electrons need something to push them along the actual circuit itself. So this is what voltage is. A force associated with an electric current that is measured known as volts. Power companies use high voltage to move power, electric power over long distances. The electrical pressure is what we call voltage and is often provided by two terminals, one which is positive, one which is negative. We all kind of remember, or can we all kind of picture in our head a positive and negative for electricity? A battery, right? This is kind of what we're looking at here. We got a positive and we got a negative terminal. So when it comes to voltage, and you guys are going to have this recap at the end of this module, we want to remember voltage as pressure. Okay. So I'm going to give you guys some examples on this. So let's talk about the voltage equals pressure. Electrons flow through the negative end and through whatever it's trying to power, and then ends up at the positive end where they'll stay unless your battery is rechargeable. Okay, so a rechargeable battery will allow it to flow freely back to the negative end. That's where power is stored. Used power is at the positive end. Okay, it's actually opposite of what you think it is. A lot of people think that positive terminals are going to provide the power. The negative terminal is going to flow through the negative to the positive. All the used energy stays in the positive. Does that make sense? So if you're plugging something into the wall, this voltage is instead provided by your power company. All right, so you're completing the circuit when you plug that thing into the wall. Although voltage just measures how strongly electricity is being pushed through the circuit, it's important because how many circuits are designed only to accept a certain number of volts. Right, so we've all seen the, who's old enough to remember Home Improvement? Right, so Home Improvement, more power. Well, what ends up happening 99% of the time, he blows it up. He didn't remember this simple little voltage equals pressure is typically the type, what's happening there, right? That's part of the joke. But you can't just add more power to something and expect it to work. You need to make sure that there's a lot of other components that are going through there, and that's where we go into our next section. Okay, amps. So what is amps? Amp is short for ampere, not amplifier. The ID. Sorry, I got to send this over to somebody. Somebody will pop in. One second. I got to get the link over. All right, can you guys see my screen again? Yeah. So amp is short for ampere, which is also a unit that how much electrical charge is flowing past a given point per second. So when you put volts and amps together, you can tell how much current is flowing and how hard it's flowing. So amp is the flow, right? This is going to be the current. So think of it like a river, right? It's the current. That's what we got to think about with amps. So we put it together, we can figure out that current. So check this out. Power formula. Amp equals flow. So P equals watts power, which equals amps times volts. So if we want to figure out our power, which is our watts, and this is how we calculate system sizes, we got to figure out the amps and the volts. We multiply those together and we're going to come out with the actual wattage itself. So when you put the volts and the amps together, you can tell how much current is flowing and how fast it's flowing. So let's suppose you've hooked up your water wheel to a generator. You're trying to create some power, okay? And you got a water pistol. So we've all used water guns before. It's going to force water through the small nozzle, which means that the total volume flowing per second, it's not very much. You don't have a ton of water that's coming out of there, but it's high pressure, and it's enough pressure to turn that water wheel, okay? So just think about this for 1 second, and we'll finish the example there. So we got the water gun. We got that little bit that's coming out, but it's a high pressure stream. So there's not a lot of flow, but it's high pressure. So it's actually spinning the wheel. Now, imagine we replace that with a wider hose. So even though the wider hose doesn't push out the water as strong, more water flows per second, and the wheel ends up spinning at the same speed. Is everybody following me? Cool. So we have the same amount of pressure, but it's wider, which means it's going to come out a little bit slower, but because there's more, it ends up pushing the same amount, which means this very simply. If we think about the hose and the water gun pushing out electricity instead of water, we could say that they're delivering the same number of watts because they're pushing it at the same speed. So even though the amount that comes out at the end is different, the wattage is going to be the same. Again, this is not one of the things you're actually going to be tested on. All right. So don't worry. This is for you guys to know. I'll show you guys what you get tested on at the very end. So here's an example for electricity. Okay. Now, let's say you got a computer with 1100 watt power, full supply on a full load in North America. Our outlets out here are 110 volts. Okay. We're going to reverse engineer that example earlier. So we're actually going to take the watts divided by the volts, and that's going to give us the amps. We have 10 amps. Okay. So our flow is 10 amps. So that's going to be the diameter of the hose, right? Well, in Europe, they have a 220 volt outlet. So we're going to have a little bit more pressure. So let's take a look at that. We're going to divide it, and you're looking at 5 amps. So that's that wider, the wider nozzle, right? That's the hose. Well, the amps are different, but guess what ends up being the same at the very end? The wattage. So because even though these are different and these are different, because the wattage is the same, can we power both the computer in both places? The answer is yes. Because the watts are the same, the computer will work in both places, even though the volts and the amps are different. Okay. Now, kilowatt hours. What is kilowatt hours? So just so everybody knows, is it a unit at a time? Nope. It's not a unit at a time. Why? Because scientists hate us. It is actually a unit of energy. So watts and kilowatts express how much energy is consumed per chunk of time. This is called power, which in the end is not the same as energy. So does energy equal power? Yes or no? We'll be engaging in this one, guys. You guys can unmute yourselves and say stuff. Does energy equal power?
No.
No, it
No.
doesn't. Okay, they are not the same. So a watt is the amount of electricity, energy in joules. So a watt is the energy that's going through. Okay. And the electrical device, such as a light bulb, is burning per second that it's running. So 60-watt light bulb is burning 60 joules of energy every second you turn it on. So kilowatt times hours equals energy in joules. This one's going to make more sense in a second. We're going to cover kilowatt hours more in depth in just a moment. Okay. Here's what I want you guys to remember. Here's what you get tested on. Voltage equals pressure. Amps equal flow, which is also with the current, right? So if you get asked about the current, it's also amps. And resistance is anything that would slow down the water in between. So like if you kinked the hose. That's what we're talking about there.
We'll be able to get this information to study before the test, right? Or this is what this is right now.
Upload this tonight and send you guys the link.
Okay, awesome.
It takes me probably about an hour or two to save the video directly to my device after, and then like another half hour to 45 minutes to upload it to YouTube.
Okay, sounds good.
All right. So these are the three things I want you guys to write down. Voltage equals pressure, current or flow equals amps, and resistance. This is like a kink in the hose, okay? This is putting sand inside of a hose, causing it to not flow appropriately. Leave this up for another 10 seconds, give you guys a chance to write that stuff down. All right, so I will pause for questions here for just a moment, but if you guys, excuse me, if you guys are good with that and understand those three basic components, you're good to go. Okay, we're going to go into kilowatt hours here in a second. So any questions? Nope. All righty then. Let's do this. Photovoltaic solar. Now we're actually talking about just the solar side of it. Okay, so just like we talked about in the beginning, that original definition was very simple, right? Your bill comes to you in kilowatt hours. That's what we're going to be talking about now. So a kilowatt is a measurement of power, while a kilowatt hour is a length of time something can use a kilowatt. Okay, so remember we're talking about with energy in joules, right? It can burn it for an entire minute. This is that hour mark. So this is why it's called kilowatt hours. So when we have an 8 kilowatt system, it's going to produce kilowatt hours. It's how long the house is able to use that in an hour, the amount of power. Okay, that's what we're building. So 1 kilowatt hour is equal to 1,000 watts sustained for 1 hour. PV solar system size is calculated in kilowatts, kW. The size of the system is determined by how many kilowatt hours is needed to be produced. So, simple yes or no again, guys. Is kilowatts and kilowatt hours the same?
No.
No, right? You have kilowatts, which is how we're going to size the system, and kilowatt hours is what the consumption is going to be, is what the customer needs to use to power the home. Okay. Again, a lot of this stuff is going to seem overwhelming. It'll all make sense on Thursday. So the PV system generates power at the panels, converts it from direct current to alternating current at the inverter. Then it uses the power of the home, and the excess power is sold back to the grid in the form of bill credit. This system stops flowing when the grid is down. So if I have a solar only system with no battery backup, when the grid goes down, you still don't have power. You may hear some companies out there tell you, oh yeah, no, you might get trickle power. There is no such thing whatsoever. That does not exist. there's what's called rapid shutdown, and we're going to learn more about that here in a little bit when we talk about inverters. But it shuts down the power from the inverter back to the grid and back to the house. That ensures that first responders and electrical workers can be safe when working on the grid during a power outage. So if you guys are asked, when the system goes down, true or false? When the system goes down, your solar is still working and powering your home. True or false?
True.
False.
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 Right? So just remember this diagram right here. As soon as there's an X right there, boom, there's no power whatsoever. So we need a battery in that situation, which we will learn more about. Okay? Super simple module. Just learning about photovoltaic and solar and all that other stuff. Now, quick definition for you guys. Photovoltaic, I'm gonna let you guys write it down because I forgot to actually put it on the slide. Write that word down. Photovoltaic solar. Photovoltaic solar.
Photovoltaic.
So all the stuff that's going to be on the test is what you're sending us tonight.
There's gonna be variations of it. Everybody who's taking the test was like, it was relatively easy after Thursday. Like this was actually pretty simple stuff. Because we're going to take these definitions and we're going to put them to the proposal. And once you see them in the proposal, all this stuff ties together and makes a lot more sense. Okay. But some of the stuff that I'm pausing on, like right here, where I may stop and ask you a question like, hey, does voltage equal pressure? Yes or no? Yes.
Yes.
That may be on the test, right? This definition right now, if I took off this word solar and it still had photovoltaic, photovoltaic is a scientific word for solar. So if we see photovoltaic module, that means solar panel. Photovoltaic solar, it basically means solar. Okay. If you see PV, that's short for photovoltaic. And there's actually a little definition at the end of this that shows you guys that. PV is short for photovoltaic, which means solar. So if you see solar system, solar module means solar panel. Photovoltaic means solar. Module means panel. And I actually have a cheat sheet for you guys on this one too. So you guys will see that one. You'll thank me in a minute. Any other questions about that before we jump forward? Okay, cool. Azimuth. So this is the first long section that we're going to talk about. And it's really important. So I'm going to go over it slowly and in depth. What I'm going to do is I'm going to make sure that everybody's muted, but when I ask, if you guys just press your space bar, it'll allow you to unmute temporarily so that you guys can hop in and answer questions and stuff. Okay. That way we don't get any feedback. So azimuth is going to be that first big section we're going to talk about. And it's actually one of my favorite ones because it is commonly, it's commonly confused for a couple other things in solar. You guys will be pretty much the only solar reps that I've ever, that are in the field today. Solar Panel Pro certified people will know what an azimuth is. You can ask David and Matt over at Titan. They actually said it to me and Brian. Well, no solar rep knows what azimuth is. Ours do. Okay. So here's what azimuth is. Azimuth is the direction of the solar panels from the observer, expressed as an angular distance from north or south point of the horizon to the point at which a vertical circle passes through the object, intersects the horizon. Okay, I put that in there just to confuse you guys. Here's a simple point of it. It looks like a cross, right? So at the top point or north, you're looking at 0. At the bottom point or south, you're looking at 180. From right to left, on the east side, you're at 90, and on the west side, you're at 270. So which means in between, you're at all those points in between. We're just going to go back to do some simple math here in a second, because every 45 degrees gives you that middle point, right? Check this out. I'm going to make it even simpler for you. It's literally a compass. So the azimuth is the actual direction that the panels are going to be facing. That's the simple term. It's the direction the panels are going to face. That's it. So what does this mean for solar? The direction of the panels directly impacts the production of the panels. This may be on your test. So does azimuth directly impact the production of the panels?
Yes.
It does, 100%. It is the direction of the panels. North, south, east, west, 0, 180, 90, 270. Okay. So I'm going to give you guys examples about how we do this. So let's take a look at this house. So the ideal solar azimuth for peak production in the south is 180 degrees or due south. This can change from geographic locations from time to time and elevations. We handle it on the back end. You guys are not going to determine what the azimuth is. I'm going to explain why it's so important for you guys to understand shortly. So from sunrise to sunset, the solar panels receive the optimal amount of sunlight to produce the required kilowatt hours. This may vary depending on the consumer need. Okay, so check this out. When mixing multiple azimuths, the factor changes and requires a higher kilowatt per system size to produce the same amount of kilowatt hours. What do I mean by this? So if ideally we're here on the south side of the roof, we can actually, let's say we need, let's get my clock out here. 12,000 kilowatt hours, 12,500 should be 7 kilowatt system. Yeah, 7.3. So say we need 12,000 kilowatt hours, right? Well, we're going to need 18 panels on the south roof to do it, to be able to produce that 12,500 kilowatt hours. There are more examples, and there's actually a cheat sheet on this, so you don't need to write everything I'm saying down, okay? When you hear it again, it'll make even more sense. So putting it on the south side of the roof is going to be great. However, if I take that same 12,500 kilowatt hours and I have it on the east facing roof, because right here, I don't have enough room, or I have to put some here and some here. I'm going to have a different direction, which means I'm going to need a 7.8 kilowatt system, which means that I need 19 panels. I need an extra panel to be able to produce the same amount of power as a house that is due south. So what this means for solar is simple, okay? When we're looking at a map, it is automatically placed north, south, east, and west. So if you pull up Google Maps or you pull up Apple Maps right now, you're looking at the north side on the top of your phone, south side on the bottom. On your right, you're at east, and on the left, you're at west. Okay. So here's a true satellite view of Southern Arizona here. So this is actually one that I pulled up. Let's determine a couple azimuths for these homes, and you guys will understand what I'm talking about by mixing these things and why it's so important for you guys to know what an azimuth is. So first, we're going to pull up our compass so we know what we're looking at. So let's take a look at the first one. So if we look at this house, we're going to be on this roof right here. We're going to be facing 275 and 295. You guys see how that works right there? There's really no south facing roofs the way it slopes. So the slope of the roof will determine the actual azimuth itself. Well, what about this one over here? This one's a 225. It slopes from east to, or it slopes to southwest to northwest. Production lessens dramatically anytime you go on the north half of a roof in most of our territories, which is why we teach this as a standard. Okay. So what we're looking at is if we're on a 225, we're southwest, this house is still really good production for solar. Well, what about this house over here? This is a 170 azimuth. Look how it's pointing down towards, it's not exactly at the 180, it's about a 10-degree offset, okay? Why is this important? Well, it's extremely important because look at this house right over here. That's also about a 170 azimuth, right? Well, they may have a similar build to this house over here. The problem is that they have less roof space and they're from east to west facing on their roof. Well, actually closer to southeast to northwest facing. So this system would actually need less panels than this system over here to get the same kilowatt hour production throughout the year. Okay. Here's what it means for you guys in terms of a sale. You sold this guy 6 months ago. He refers you over to his buddy right over here where they were drinking one day in the garage and he goes, I want to get solar. So he sends you over. Yeah, my buddies and my bills were, they were exactly the same. Why is my system size 10 kilowatts and his is only 8? Well, Mr. Customer, here's the deal. His is actually almost completely south facing, which means from sun up to sundown, he's going to get more direct sunlight on his panels, which is what's needed to produce the most power. Okay. You need direct sunlight to do that. So since from sun up to sundown, he has power on or direct sunlight on those panels pretty much all day, he needs a little bit smaller of a system size. For you, well, at about noon, guess what happens to these panels that are right over here? Can anybody tell me what they got? My guess?
Stop getting direct sunlight.
They stop.
They're
getting
no longer in direct
sunlight.
sunlight.
Exactly. So they still produce very well, but they don't produce as much as they did during the first half of the day during sunrise until noon when it passes that peak. Does that make sense to everybody?
Yes.
So the solar company that installed this, do you think they did them a service or a disservice by, do you think it was good or bad that they only installed them on one half of this part of the roof?
Bad.
Bad. They would want to
Bad.
split them up and put half of the panels over here as well. Is it starting to make sense to everybody now?
Yep.
I know it's
Yes.
a lot of information. Do I need to repeat any of it?
You said something about the slope of the roof. Can you go over that again?
Right. So take a look at this part of the slope of the roof right here. Okay. So right here, this is going to be sloped south, which means that when the panels are put on, they're put flush. They're facing like they go from the top the same way that the roof is built, right?
Okay.
That's what I'm talking about by the slope of the roof. Because even if we turn the panel sideways like these ones over here,
Mhm.
it wouldn't change the slope of them, right? It would just change the direction that they're laying. They'll produce exactly the same.
So are the actual panels a exact size? Like that doesn't change, or?
They can vary depending on size of the or the wattage of the panel. Most of our
Okay.
panels are about 4.5 feet by 3 feet, up
Okay.
to 5 feet. But then when you start getting to like these 500 watt panels, they can be up to 6 feet tall. So they can vary. The ones that we're using are at about 4.5 to 5 feet to 3 feet. And you guys, I'll have exact specs for you guys on those.
Okay, perfect.
So you can guys already see that there's a lot of factors that go into this stuff already.
Right.
You guys only need to know like 10% of this to sell it. But you will get those engineers every once in a while who are like, hey, so why'd you guys use the south side of my roof? And they're just testing you. Well, what that means, Mr. Customer, from sun up to sundown, you're going to get the most direct sunlight on those panels. It's actually, you have a really perfect house for solar. Well, you have a good house for solar over here, Mr. Customer. So we have to split up the panels on this side and this side. That way, during the first half of the day, you get direct sunlight on these panels. They'll still produce, but they're going to drop production because these panels are going to get the rest of the direct sunlight. Pretty simple explanation, right, guys?
Yep.
Come back and listen to
Okay,
this one 100 times if
So
you
this might be a stupid question. So
want. No such thing.
as far as the roof itself, so is this just like a visual thing? Like, are we actually gonna have, is there like a website or something where we can like look at the roof like this? Or are we just like eyeballing it from outside? How are we actually determining what is best? Does that
We
make sense?
do it. We do it for you guys.
Okay, so I'm not there telling like
Nope. So, and you guys will actually get a roof drawing that
doing
looks
a full
just
visual
like
of
this.
and
It'll
explain
look
where
a lot
everything needs to
closer.
go. Gotcha.
Yeah.
Okay.
So I'll show you guys what the roof drawing looks like for, because I actually have a proposal in there. And it's for a customer that's on a new build. So I just threw one up and I didn't realize that there was no house on there, but just give you guys an example. There will always be a roof drawing and it will always be north, south, east, and west. So you guys will always know what you're looking at. So, you know, if you sold a customer before, you saw that their house was like this one, it'll just be a lot closer. That's all it'll be. It'll be a lot closer view on their house. And I'll show you guys what that looks like. Any other questions for me?
So on that one house at the top where they should have done it on both sides,
Yeah.
right? Yeah. Would you have done those same amount of panels that they got on there now and just split them up, or would you double up on that and put, what is that?
They probably put the right amount of panels, but the customer is going to see a decrease in production. So they probably would have needed that. They probably built the system right on paper, but working correctly, it's not gonna function the way that the customer wants it to. And that the way
So is it like just all depending on how many panels the customer wants?
it's depending on what we build for them. So we can add panels, we can take them away. So I'll show you guys how that works. So when it comes to sizing the system, you guys are going to learn sizing the system here in a little bit. So I don't want to go too far off topic, just about the azimuth part. But yeah, so I would have just split these up and put 50-50. Depending on the proposal writer, when they were writing it, they should have done some different calculations and figured out like, hey, maybe we needed, 5 panels over here and 6 panels over here. I probably would have only put, maybe a 60-40 split, 60 on the southeast roof, and then on the northeast roof, put 40%. Does that make sense? So it wouldn't be your guys' call on how this is built. We do this on the back end. What you guys will probably have to explain is, yeah, I know your buddy over here has a smaller system than you, and you guys have the same bills every single month, but it's because his is south facing and yours is left to right. Yours is east to west. So it's the direct sunlight aspect that covers the power. Any other questions on that from you guys? Oops. Yeah. No? Cool. Tilt. So tilt is another one. So these two get confused from time to time. I'm actually going to show you guys a video. Actually, I'm going to go ahead and put it in here now because I keep forgetting to do it. Like 6 times I've jumped back and forth. So give me like 2 seconds while I put it back in to make your guys' lives a little bit easier. Yeah, I built these training decks just for the lives. We have feedback. You guys gonna mute? Yeah, because we used to have a ton of there we go. Duplicate. So everything is actually all animated on the training videos. So I built these so that it's a little bit more of a conversation rather than so we can actually have this conversation rather than you guys just listening to me talk for 2.5 hours. So tilt. Screen share. Can y'all see my screen again? Perfect. All right. So what is tilt? The tilt of the solar panel is also known as the pitch and will impact the amount of the tilt toward the sun of the PV ray. So it is the tilt towards the sun. Most arrays are flush mounted, meaning that they follow the same pitch as the roof or the slope of the roof, as we talked about earlier. But the array's a few inches above. So there'll be a racking system that will keep them about 3 to 6 inches above. So we can access those in the future as well. Okay. And for airflow and all that other good stuff. If the roof is nearly flat or it is flat, it may be desired to tilt the solar panels on the roof to achieve the optimal angle towards the sun. So this is that one that you guys might see some crazy stuff where weird systems are built, right? I'm going to show you guys a couple examples of those. So this may be on the test. Does location affect tilt? 100% yes. Geographical location is the major factor. Because the Earth rotates around the sun on a tilted axis, higher latitudes, areas furthest from the equator will yield lower levels of production. Just like it's possible to get a sunburn on a cloudy day, solar panels can produce energy even from indirect sunlight. So direct sunlight will produce the most amount of power. Indirect sunlight may produce a little. So it's like those old solar powered calculators where you get some fluorescent lighting and it still turns them on, right? So you're not directly in the sun, but you got some light. It'll produce a little bit, but it's not going to produce enough to power the home, likely. So this is one of the factors that we put into place. So this is what our proposal writers like when I say you guys are learning just a mile high overview of this so far, and you guys are going to be tested on a mile high overview of what you're learning. Our proposal writers are put through the ringer. They know like every peak sun hour and all that other stuff. So we have to go through a lot to be able to teach them this stuff. Because yes, we have calculators to do all this for them, but there's a factor that needs to go in to make sure that these are done correctly. So right here in the Southwest where I'm at and where some of you guys are in parts of Texas, look at all this bright orange and red. This is going to be the highest point. It's going to produce the best and the most amount of sunlight hours on those panels for direct sunlight. Okay. When you start seeing this blue, this is all indirect sunlight. So it's cloudy. There's not as much sun. They're not going to get as much production. Green, it's the same thing. So you can see over in New Jersey and all this area right over here where we still service, we still have a lot of yellow, right? Florida still in pretty good orange. So the reason why Florida has a high kilowatt system size on average is because they need more panels to produce the same amount of power typically than we do over here because we get more sunlight hours. So they're going to need a little bit bigger of a system sometimes, not always. Again, we determine it on the back end, not you guys. So does the roof type matter? This might actually be on the test as well. So does the roof type matter? The answer is 100% yes. Depending on the part of the country, the builder, or even personal preference, there are different type of roof pitches that can and will directly affect the solar installation. This will directly impact the tilt of the solar panels. Conventional slope roofs and most common with residential roofs. This means that the slope is between 412 and 912 on most homes. Roofs with a pitch exceeding 912 are considered steep slope roofs, and we can't even walk on those, so we don't even install on them. Okay. Here's a couple reasons, or here's a couple things for you guys to understand. So on a 412, we're typically going to be pretty flush to the roof. It's just going to sit on the roof. It's going to go in the same slope, same direction. Let me just go to that video real quick. There it is. So when a customer asks you like, hey, so, is it going to be sticking up above my roof? What they're worried about is it looking like this. So if we got the panel sitting right here, I got to shorten this thing. So if we got the panel sitting right here, they don't want the panels looking like this. Have you guys all seen installations like that before?
A
Couple, right? The customer doesn't want that. We don't have to do that. So we're just going to sit it so where it looks like it's completely just flush and part of the roof. Okay. Now, the reason why it does affect it so much. So let's say you need to be at about a 20 to 25 degree tilt. Well, we can put that right here on this roof and it's never going to stick up. It's just going to sit flush right against it. Okay. Can we do that on this roof? Well, we're going to end up sitting it flush, but it's not going to be at the ideal tilt because we can't exactly take a chainsaw and cut back the customer's roof to lay the panels at the desired tilt, right? That's what we mean. All these can have an effect. If we lay them too flat, we don't get as much direct sunlight. We can't capture it. If we lay them too steep, then we're not going to capture as much direct sunlight, which means that we're not going to be getting the optimal amount of production for the customer. So here's how this looks. Okay, so take a look at this flat roof right here. These are multiple different angles that I put up here for you guys so you guys can take a look. Adjusting the tilt can help compensate for losses based off a geographical location. By adjusting the angle of the panel, the amount of direct sunlight can be controlled. For the solar panels to get their best performance, a steep angle of 60 degrees is best during the spring. The best is 45. And during the summer, when the sun is at its highest in the sky, a low tilt of 20 degrees. Best solar panels are because solar panels are mounted on the roof, it is important to determine the best angle for year-round production. So this is where the customer's bill comes in. This is why we ask to get a picture of the bill. Because on the bill, and you guys will see, just like we saw yesterday on the bill review, the graph shows when they're using the most power, right? So when would we want to produce the most amount of power for that customer? In this winter when they're using no electricity, or in the summer when they're using their AC 24/7?
During the summer?
During the summer,
Um,
right? So we determine that on the back end. Again, it's not something you guys will ever determine.
Okay, now let me ask this. Okay, so talking about the adjustments, is an actual adjustment done? Like, does somebody actually come out? Does that make sense?
No, once it's fixed to the roof, it's fixed to the roof. So we determine what's going to be the best for the customer. In most cases, sitting it flush against the panel, flush against the roof is not going to be an issue. Because it's just, we're going to have to add an extra panel or two to be able to achieve the right amount of solar production throughout the entire year. So if their roof is a 612, which is roughly about a 45-degree angle, that could be best for year-round production in that area of the country that they're in. If they're at a 412, like down in Arizona, which is
Gotcha.
pretty much standard until recently, that's at almost a 20-degree. That's perfect for year-round production for Arizona. So roofs are pretty much already built to what we need them for. But if they have a custom build, like right now, a lot of the new homes that are going up, they're all 612, which means that, yeah, we're at almost a 45-degree angle. We may need to start, we're like what our proposal writers do is they're going to add a couple extra panels because that comes off of the sunlight factor. So there's a
What
big
about
range
like
of outdoor.
Adobe, like what about like Adobe style homes with like flat roofs?
Great question. Flat roof solar. I got you. Installing flat roof solar, I love it. Absolutely freaking love it. Is my absolute favorite to do. It is so easy to do it. Installing flat roof solar requires a different type of racking system, an offset of at least 3 feet to adjusting the solar panels to the correct tilt. Okay, so here's a good example for you guys. The largest benefit of flat roof is that the system can be installed in virtually any azimuth at any tilt. It doesn't matter because we can just set them wherever we need to catch the best sunlight, right? If we need to turn them slightly this way, so we're at a 180, then we need to be at a 33-degree pitch for the or tilt for the year. We can do that with a flat roof. Can we do that with this roof back here?
No.
No.
No,
No.
we have to cut into the customer's roof and just basically redesign it, right?
Yeah.
So take a look at the tilt on this. Would that have been ideal to put it here?
No. Pretty close.
Pretty close, right? So can it be done? Absolutely. If the customer wants it there, absolutely. Our job isn't talk them out of it. It's just to give them the best, give them an idea about why we put it where we put it, right? And then in Arizona with most Adobes, like my house, I have an Adobe. I have a 3-foot parapet. So I have 20-foot ceilings and I have 18-foot ceilings and 20-foot parapet, or sorry, 3-foot parapet, which means it's about right here. So people can't even see the panels that are in our neighborhood. Nobody knows that any of our homes out here have solar. Okay. So does it matter which direction I put these panels? Do you think the customers care?
Nope.
No. It's amazing. I love them. Okay. Now, here's something else that's important to understand. So just like I talked about before, they need to be offset at least 3 feet apart. Solar panels will cast a shadow behind them because of their angle. To avoid creating shade on the rest of the equipment, the correct distance between the panels is necessary. Too close and the shadow can affect production. Too far apart and you can reduce the number of panels that can fit on the roof, affecting the system size. Does that make sense to everybody? I got some more examples to show you guys. So let's talk about this one. So take a look. This guy's casting a shadow, right? But look also what's happening here. The panel itself. So what we do on the back end as well, we do a lot of stuff to make sure these are done. That's why we ask you to give us a couple hours before creating a proposal. This is why we don't typically do same days, or you give us an hour or two before we create the proposal, because our proposal writers take this seriously. Now we have all the algorithms and all that stuff that do this typically on the fly. We just go back in and we double check, because if we cast a shadow on this panel, it's going to drop production. We're going to learn about that in the next module, which is shading. So we're going to take the angle and we're going to go ahead and take where the peak sun is, and we're going to make sure that those never intersect each other and the panels don't ever shade each other. We can't control if a bird flies on the panel and shades it. We can't control if debris shades the panel and stuff like that, right? But what we can control is the equipment shading itself.
So I have a question too about that. So is there any kind of maintenance provided with our services or cleaning or anything special? Do we
No.
do any of that or is that?
There's a third-party service that provides it. We have a couple of different companies that we can refer out. Panel cleaning should be done once every couple of years. It's like 100 to 150 bucks.
Okay.
No chemicals. For most of our customers, they spray it down with the hose and that's all they ever need.
Does it
Okay.
does it make leaves on the roof a lot worse or
No,
no? Okay.
if they have netting, it can cause that. So they need to go up there and dust them off more, but it's very good. The way that they sit, they usually just blow right off. It's not a big deal.
Right on.
Any other questions about this part? No? Okay, cool. So here's a recap basically about what we're talking about. So on this house, look at what they did. Why is the tilt different? Well, the solar company did a pretty good thing for the customer. So like, okay, cool. Summer, they're going to collect a ton of power here, direct sunlight. They're still going to collect a ton of power here, but throughout the rest of the year, when the sun's a little bit lower, guess what? These panels are going to produce more, right? So aesthetically, it's very, very pleasing, but here it's all function as well, right? So there's a way to do function and aesthetics at the same time. So this is what we're determining throughout the year, and we use the customer's electric bill to help determine this. The layout, this layout would be more effective year round than most solar installations. Depending on the position of the sun and the time of the year, each different tilt will deliver a different production, creating a more effective solar installation. So look at the angle of inclination is basically what we're looking for here. So what we've determined with this one is that we're going to need a 43-degree tilt year round to collect the best. So in December, where these guys are located, they're going to need 23 degrees because that's where the sun's going to be. They're going to need 47 in March, and they're going to need 21, or they're going to need 70 in June. So at 43 degrees, we can capture all these and give them the best peak solar production. Does that make sense right here? So we're just going to use the law of averages to make sure that we're building out, we're putting these things at the right angle to build it out. So it goes back to one of those things. You guys don't have to sit there and question it with the customer. All you got to do is, this rarely ever comes up. You guys learn about it because it makes life so much easier. Like why, again, it goes back to the customer question. This is usually the only time you guys talk about this stuff with the customer. Azimuth and tilt come up when customers have issues with referrals. Like, hey, my sister's brother's aunt's uncle has the same usage as me and my system's bigger. Why is that? Or my system's smaller. Did you rip off my mom? No. So your mom has a pitched roof. So she has a normal just sloped roof. So we got stuck installing the panels where exactly the roof slopes, and we put it like that. With you, you have a flat roof. So we're able to put the panels wherever we want and tilt them however we need to get you the best production. So we can actually create the same amount of power with less panels than your mom's house. That's all you guys need to take out of all this.
Yep.
Pretty cool, right? So yeah, I messed up your guys' brains for my own amusement, basically. No, I want to make sure that you guys understand we do put a lot in this because, again, you guys have to be confident in what we're doing for you and that we built the right system for your customer, right?
Right.
So I'm not teaching you this for no reason. You will have these conversations more often than not. So for instance, I had to help out somebody earlier today. They called and they're like, hey, my customer's reviewing all kinds of proposals. They already love us because we're having, we gave them more information than everybody else. And we don't flood them with information, but they were able to answer their questions. We teach them how to read the proposals, right? So she loved the guy, but he was just, I can't remember what the biggest question was. It came down to system sizing. So I've gone on like 10 different phone calls today, but that one just stuck out to me because it was system sizing, and I just had to remind them about this. So if you guys don't remember this, it's okay, because guess what we can do if you're inside of a house and you don't know. Hey, Chris. Hey, Vinny. Hey, Brian.
Questions, yeah.
Yep.
So I have a kind of off-topic question. All of the notes that we've taken, are we able to use them on the test?
Yes.
Okay.
Yeah, I'm not
Cool.
going to go to your house. Any other questions? Cool. Yeah, so my favorite response to a customer, because I still say this today, there are things that, maybe I don't know. I don't know everything. I know a lot. The reason why I know a lot is because if the customer asks me a question, that's a valid question, deserves a valid answer. Let me get back to you. And I pick up the phone and I call somebody who would know. I don't know. Let me find out and pick up the phone. Don't lie your way through it. Don't try to sound smarter. You just seem like an idiot. I promise you 100% of the time, customers know when you're lying and you're trying to talk your way out of something. Just be honest. I don't know, but I'll find out. And then get on the phone. We'll answer the question for you. Brian and I were just doing that with Vinny. That's why we started an extra couple minutes late, or not with Vinny, with Gabriel, because Gabriel had a question and he called me. So I three-way, me and Brian were already on the phone. So I just went ahead and patched him through, and we we're trying to help him figure something out real quick. So if I don't know it, trust me, I'm going to call somebody and I'm going to find out. It's very rare. You guys are going to come across a question now that I don't know, but it still happens. Any questions about tilt? So let's do a quick recap. So if we're talking about voltage, that equals pressure. If we're talking about amps, that's the flow or the current, right? If we're talking about resistance, that's something that's going to get in the way of the current or the flow, like a kink in a hose. And the azimuth, like we use a compass to determine that. It's in 360. So we have 180 at the south, 0 at the north, east is 90, and west is 180 or 270. And the slope of the roof is going to basically determine where we can install those panels. Azimuth does directly affect the production of the system. Tilt directly affects the production of the system. And the tilt is going to be determined based off of also the pitch or the slope of the roof. But flat roofs answer that question for us, so we don't have to worry about that. We can install them however we need. So you guys learned all that information just to kind of get that out of it. That's what I want you guys to understand out of this whole thing. Any questions about that? Sweet. Shading. So we've been here about an hour. Let's do 20 more minutes and then let you guys take a 15-minute break. Sound good?
Yep.
Yeah, that's good.
All right.
Yeah.
Solar panel shading. Exactly what it sounds like. Shading a solar cell is similar to introducing a clog into a pipe of water. Resistance, right? The clog in the pipe restricts the flow, amps, of the water through the entire pipe. Similarly, when a solar cell is shaded, the current through the entire string is reduced. If only one cell out of the usual 60 cells in one of the panels in your solar array is shaded, the overall output of your system can drop by 30 to 40%. Much like a clog in a pipe or a kink in a hose, if the current flowing through your solar panels is interrupted by the shaded cell, the end output is throttled. It doesn't matter if it's at the beginning or at the end. Wherever you kink your hose, you stop the flow, right? This is what happens with solar panel shading. So let's talk about this. Partial solar panel shading. One of the many factors that is directly responsible for the degradation of output power is partial shading. So partial shading cells produce less current than other normal cells exposed to sunlight and behave like a reverse bias PN junction. So as a result, it dissipates power instead of generating and gets heated. Here's problems. Have you guys' cell phones ever got hot and stopped working?
Yep.
What happens if the electronics get too hot over a long period of time? Who had a Samsung back in 2015? There was a fear there for quite some time, right? If something gets too hot, it can die. Okay. It can cause fires, all these other things. Well, the good news about solar panels is typically it's not going to cause some type of a fire. All right, so we don't have to worry about that.
That happens a lot out here in Arizona.
Yes, there's a lot of heat, right? So here's what we have to worry about is that heat factor when it comes to clogging it up. So we actually use everything on the roof, whether it's a ventilation pipe, whether it's a chimney, or whatever the case may be. All these are factors in the actual system itself. So all 5 of these panels are now reduced. All of them. 1, 2, 3, 4, 5. They have all reduced power by up to 30 to 40%. We're going to get into string and all that other stuff later. So, which means that you put a clog here. Is the rest of the solar panel now producing at 100%, just not where that is? No, they're all functioning together to give you an end output, right? Which means by the time it gets to that point, you're only going to get out as much as you kink the hose. So when you want to get your when you're trying to walk from one end of your yard to the other without spraying water everywhere, what do we do with our hose?
Kink it.
Kink it, right?
Kink it. Yeah.
That's going to stop the actual flow. If we want a little bit less, so we don't damage a delicate plant or something like that, we're going to kink it just a little bit so that we just have a trickle of water coming out, so we don't have to turn down the faucet, right?
Right.
This is what you're doing. You're actually just kinking the hose a little bit here. But what's happening to these cells is you still have the same amount of voltage that's getting pushed through, which is pressure. So all that's doing is just pounding away at that cell. All that pressure is pushing through. It's going to eventually heat it up and start killing that cell.
Right.
So we don't want shading on solar panels because it'll help. It will cause more degradation over time. Does that make sense? Okay. So unshaded cells, partially shaded cells, and shaded cells. So an unshaded cell is 100% current and voltage output, which means we're going to come out with 100% of the wattage that we were originally trying to put. Partially shaded is the output current directly proportional to the illuminated area of the cell, no voltage change. So the voltage doesn't change, the pressure is still the same, but you're only getting power here, right? Which is going to cause a clog. When you're completely shaded, there's no possible output. A shaded solar panel will not function. It's the same as no sun on a cloudy day or being at night, okay? So overall, I'll unmute everybody so we can start asking questions. Well, you guys can just press your space bar on mute. What kind of questions do you guys have about shading?
So you mentioned as far as like chimneys and stuff like that. So do we know that there's going to be a certain amount of shading just due to those factors? I mean, is that just a given?
It's going to
Or
happen.
are we gonna...
Yeah, so we just avoid putting them near those to begin with.
Gotcha. Okay, that's what I was wondering. Okay.
Yeah. So we have a bunch of really cool tools that allow us to, it's just part of our CAD programs where we can determine the height of that object and the average
How far?
shade. Yeah. And where the shading is going to be on it so we can keep it away from those.
Gotcha. Okay, now tell me this too. So is there a way? So for example, is there something that could possibly obstruct it? Say like a limb fell on it or something like that. Is there a way for them to determine by their bill or something to let them know that there's a factor causing an issue because it's not producing as much power?
There actually is, because our system allows them to monitor each panel individually, so they know when the system is not producing at 100%.
Gotcha.
So I'll show you guys how that works with our inverter.
Okay.
Hey, Brian, are you on right now?
Yes, sir.
Johnston.
Yeah.
Oh, is it you? Sorry.
Yep.
Can you get a hold of Ronnie Lopez? He's having trouble getting on the Zoom. He's had trouble for a while. Can you reach out, send him all the stuff?
Yep. I'll get a hold of him now.
And then he can just catch up by watching the video I put up on YouTube tonight.
Cool.
All right.
I'll
Thank
ping
you.
him. Yep.
It didn't sound like you for a minute. So let's talk about solar cells, and then solar cells. We'll go into the inverters after our break. Okay. This one's fun. So this is where things get a little tricky for some people. Again, guys, you're going to be overwhelmed today. It's designed to be this way. I promise you, it's going to get easier. So let's take a look at here. So we have a transparent glass. We have photons being thrown in. We have the conductors, which is going to be our solar cells, and then it's going to move to the electrical device. Okay, so this is how it's powered. Now, there's different types of solar cells. Monocrystalline solar panels. Each solar PV cell or solar cell, right, photovoltaic, is made of a single silicon crystal. These are sometimes referred to as monosolar panels. Polycrystalline solar panels. Each PV cell is made up of multiple silicon crystal fragments that are melded together during the manufacturing process. You may see them called multicrystalline or poly panels. Now, here's an easy way to remember this. Mono equals one, poly equals many. Okay? We'll determine which is better here in a moment. So here's the monocrystalline panels. So we've all seen the black ones coming up nowadays, right? Here's how this works. Monocrystalline solar panels are characterized by their black PV cells. They're rounded with the rounded edges. They have a higher conversion efficiency than polycrystalline panels, which means they produce more kilowatt hours of electricity. If you want to install a solar panel system but have limited space, monocrystalline panels will be the most productive per square foot. While they're the most efficient solar panels, they're also the most expensive solar panels, since the manufacturing process of a single crystal silicon cell is more complex. Now, polycrystalline is a little bit different. Polycrystalline has a blue hue with straight edges. So if you ever wondered why some of these solar panels are blue and now they're black, now you understand. Some of them are poly panels, some of them are mono panels, right? So blue panels are polycrystalline panels. They have a lower efficiency compared with monocrystalline panels, which means you need more panels to reach the same power output. However, polycrystalline panels have a lower price since their manufacturing process is simpler. Polycrystalline panels are very durable, but they tend to last slightly less than monocrystalline panels. They are also affected by high temperatures, which reduce their productivity on hottest days. So far, which panel do you think is better? Mono or poly?
Mono?
Mono.
Which do you think is customer favorite, mono or poly?
Probably Poly's probably
Probably
customer
poly,
favorite.
right.
Yeah.
Always mono. They always want the mono, right? Like if you had a choice to pick between a Lexus and a Honda, 9 times out of 10, what are you going to pick?
The Lexus.
Lexus.
The Lexus, right? Now,
Yeah.
and for truck people, if you had to choose between a Toyota Tacoma and well, let's not do the Tacoma because the Tacoma's pretty badass. Let's do the Ford Ranger and the Chevy 2500. If they were
Personally,
pretty
a
much what you
Ranger.
end up getting.
I'm going Ranger. I have one, so I love them.
Really? You wouldn't trade it up for a Silverado for a Evo?
Oh.
I wouldn't.
would.
No.
I would in a minute. In a minute.
No way. I can't do the Rangers. I've had bad experiences.
Any Ford.
Oh man, I've had bad experiences in every Ford I've ever had. I
Me
got
too,
my
brother.
Titan. I love my
Ooh.
Titan. I got my Titan. I got my Charger. I love my cars. I'm keeping them. So check this out. Here's the key differences between the two. Okay. And I asked that question first because I want you guys to understand something. Here's a couple things to keep in mind. Monocrystalline solar panels have a higher cost when comparing only the panels. The cost of the inverters, the wiring, the electrical, the protections, the racking, the labor. So installing them is exactly the same. It's only the actual cost of the panel themselves is more expensive.
Okay.
Because monocrystalline panels are more efficient, you may get better return on your investment. Homeowners are eligible for federal tax credits, whether they choose mono or poly. This is crucial because you will have companies who are smaller, who you're competing against, who will tell customers, well, you actually have to get these panels if you want to get the tax credit.
Oh no.
This is why we came into existence, is because of crap like that.
So you can get them on either one of them, right?
As long as it's solar, you qualify for the ITC.
Gotcha.
Okay, we'll learn more about the ITC on Thursday.
26% this year, right?
Yep. And I'm like, yeah, we're gonna go over that in depth. Like, I'm gonna go,
Yeah.
like, yes, brains are gonna explode on Thursday. But then
Yeah.
it's gonna be great. So the reason why I asked between the Honda and the Lexus and all those other questions is if you could get the monocrystalline panels for the same price as the poly, do you think you'd want to do that?
Absolutely.
Yeah.
Because of our buying power with Titan, we go directly to manufacturers. We don't go to distributors. So the way that it works in the industry is distributors get a really low price from the manufacturers because they buy them in bulk and shipping containers, right?
Mhm.
Then they sell them to solar companies at an elevated price. Well, we actually just bypass the distributors and go buy the shipping containers straight from manufacturers.
Well,
Titan buys so many that they've named panels the Titan panel. They white label some of their panels with the name of Titan. But they just buy so many panels. They're like, yeah, you can name them whatever you want. You don't have to use the Silfab name or the QCell name. You can call them Titan. Pretty cool, huh?
yeah.
So we can offer better equipment at the same price. So some of this stuff may be under test. I will leave it up for a few minutes to write it down. Mono solar panels, monocrystalline solar panels. They're a pure silicon crystal. Polycrystalline are mini silicon fragments melded together. Remember, mono equals one, poly equals many. The cost of the monocrystalline are more expensive. The polycrystalline panels are less expensive. The appearance, I want the black panels. Well, you're going to go mono. I want the blue panels. You're going to go poly. You will have people who want the blue ones. They're just like, I like blue. Okay, great. Monocrystalline are more efficient. Polycrystalline are less efficient. The lifespan of the monocrystalline panels between 25 to 40 years. The lifespan of the polycrystalline panels between 25 to 35 years. Temperature coefficient, lower temperature coefficient, making them more efficient in the heat. Polycrystalline have a higher coefficient, making them less efficient in the heat. I think we'll have time to get through heat coefficient, and then we can move. Then we can take a break.
So, but hey, Chris, so besides being the longer warranty, what was your, like in your head, what's the main difference between monocrystalline and the polycrystalline?
So the same warranty is going to be the same 25 years. Okay.
Right.
Lifespan is going to be different. So just right here. So they have they produce better in the heat.
Mhm.
They have higher efficiency ratings, which
Uh-huh.
means that they'll produce more power.
Okay, more power. That's it. That's what I was looking for. I'm sorry.
They're better and stronger panels, and they last longer. So I'll leave this up for another minute to let you guys write this down, then we'll move on.
I'm good.
Actually, we'll take our break and then we'll come back and go over the heat coefficient and then the power production differences between the two. Anybody still need to write this down?
No, I think I'm good.
Hold on 1 second.
Go. Let's take 15 minutes. It's 45 now. So come back at 7 my time. Or no, 6 my time. Sorry, not 7, not an hour 15. 6 my time. So come back in 15 minutes. Okay, guys? See you in a few.
Yeah, that's good.
All right, everybody check in. Let me know when you're back.
I'm back.
Yep.
I'm back.
Cool, cool.
I'm back. I'm here.
Awesome. Yeah. I'll go ahead and get us started. Cool. So heat coefficient is going to be the next thing that we're going to cover today. So this is where we start finding those we're going to start talking about the major differences between the two panels really quickly. It's a brief section, but it's important because this is how you kind of, we call it kill the panel with polycrystalline. So monocrystalline solar panels have a higher efficiency. However, it doesn't mean that polycrystalline solar panels are inferior products. You can find high quality solar panels of both types. Here are a few of the facts about the efficiency. When a solar panel has high efficiency, it converts a larger percentage of sunlight into electricity. So as of 2021, polycrystalline panels have typical efficiencies of 20%, while the best monocrystalline panels are approaching 23%. It doesn't seem like a big difference, but when you're trying to gather the most sunlight over the course of 25 years, it absolutely does matter. When you have polycrystalline panels, you reach a certain kilowatt hour output per month. Since the efficiency is lower, all the solar panels suffer temporary efficiency drop when the temperatures increase. All of them, okay? But monocrystalline solar cells are less affected by the heat. So you will get a decrease slightly in the heat, but not nearly as badly as you would with polycrystalline panels. Polycrystalline do have pretty decent heat coefficients, but they do suffer a lot more in the heat. So the temperature coefficient indicates how much solar panels are affected by temperature. All solar panels are factory tested under the same standard conditions, or STC, to ensure fair comparisons. So this is another thing that's super, super important to understand, is that they're all tested the exact same. So these numbers are coming accurate. It's not just take a company's word for it. The standard test conditions are the same for every solar panel. So in general, polycrystalline solar panels tend to have a higher temperature coefficients, which means that they lose more productivity when they heat up. However, as technology improves, there are now some solar panels of both types with similarly low temperature coefficients. Solar panel efficiencies is not a typical factor when it comes when you have plenty of space. So since polycrystalline panels have a lower price, installing more to compensate for lower efficiency is not a problem. However, when you have limited space, installing more panels is not an option. So monocrystalline panels will maximize electricity production in the available area. So this statement isn't true, and it's also not true. So let me explain what I mean by that. Because the higher wattage of a panel, actually, I think we cover in the next slide. We do. So I'll cover it after this. The appearance of solar panels is a result of their silicon structure, since it determines how they interact with sunlight and how they are perceived by the human eye. The single crystalline structure of monocrystalline gives them a black color, while the polycrystalline cells are blue. Both solar panels have a long lifespan, while their payback period is less than 5 years in most cases. Solar manufacturers typically offer 25-year power production warranty, but some brands now come with 30-year warranty coverage. So right now, it's very rare to find one with 30 years right now. They're pretty much all 25 years. Here's something that's important to understand about this. When it comes to the power production warranty, it works a lot like like your cell phone with your warranty coverage. So if I were to throw my phone against the wall right now, I want everybody to go ahead and unmute and tell me, would that be warranty or insurance?
Insurance.
Insurance.
Everybody agree?
Yes.
Perfect. Correct. If I were to be texting and it just stopped working, would that be warranty or would that be insurance?
Warranty.
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 Simple explanation to your customer. Okay. So if they go up there and they start taking a hammer to their panels, would they have to do warranty or insurance in order to get new panels?
Insurance.
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 Insurance. right?
Yeah.
I wouldn't say it if it hasn't happened. So here's some good stuff to understand about all that. You may find, so if a customer wants a specific, give me a second. So do you want a specific color, right? Something that you can have in the back of your mind. So if they say, I really want the blue ones, you know they're going to want poly panels. You have to call your manager and have them switch the panels. Okay. Monocrystalline or black panels. Most people are going to say, I want black panels. Great. We offer that anyway. So we don't have to make any changes. Okay. Well, polycrystalline, if you prefer one or the other, you can buy solar panels to suit your taste. So here, you may find that polycrystalline panels produce 300 watts, while an equally sized poly or monocrystalline panel produces 350. So like there are panels that go up, monocrystalline panels that go up to like 500 watts, but that gets like huge panels. They're like 6 feet tall. Okay. So here's what you guys need to take out of this. If we have space for 20 of them, you're taking, it's 20 panels times 300 watts, which is a 7 kilowatt system or 6 kilowatt system. But if you have monocrystalline panels, they're the same size, but you get better wattage. You're getting 7 kilowatt system with the monocrystalline. So what they're talking about on that last statement before on that other one, the mono panels are slightly more efficient than the poly panels, right? So they perform better in high heat and in low light environments, which means you'll produce closer to the rated output in less than ideal conditions, which is important. So when you hear things like that last statement over here, I was talking about an equally sized panel, right? However, if you have limited space, installing more poly panels or installing more panels is not an option. To get higher wattage poly panels, they need to fit more cells, which means they're typically going to be bigger frames, which means it still could end up causing an issue. Okay. Now, again, this is one of those confusing things for you. Just know higher wattages are bigger panels. That's it. But on a polycrystalline panel that may be a 300 watt panel, the exact same size panel basically is going to be 350 watts with the mono because they have better efficiencies. Does that make sense? Cool.
Yes.
Is there an advantage to using bigger panels?
There's more wattage. That's pretty much the only thing. Any other questions about what we've covered so far, guys? All right. Okay. Inverters. The inverter is the core. It's what makes everything work. So we're going to go over the different types of inverters now. Solar inverters have one core function. They convert the direct current solar panels generate into alternating current, which is the type of electricity that your home uses. Okay. So two of the types of the inverters that we're going to talk about are string inverters and microinverter systems. And I have videos from the manufacturers that we use so that you guys can understand the differences. And then I will show you guys the one that we prefer to use, and you guys will understand why. Okay. So a string inverter system. What is a string inverter? A string inverter is also known as a central inverter. It is a standalone box that is typically installed close to the main service panel and electricity meter. There are typically only one single inverter or possibly two string inverters on each residential installation. It really depends on the overall solar power system size. A string inverter functions in a series circuit, which is usually being 6 to 12 individual solar panels as a series string. SMA is a leading manufacturer for string inverters. So what this means for you guys, think about them as Christmas lights. If one bulb goes out, what happens to the rest of the string?
They're all gone.
They're all gone.
We're all out.
All of them, right? Same thing. So if you have, we also call this an array. A series string is also an array, okay? If one of the panels gets shaded, it's going to drop efficiency. Who remembers what the efficiency drop is on a shaded cell?
It's 30 to
30 to
40%.
40%.
30 to 40%, right? So if I have 12 panels in a string, let's just say these 6 right here, this one gets shaded on the corner. What's the efficiency drop on the entire string?
30 to 40%?
30 to 40%. Do you think that's effective for most people?
No.
No.
No, they don't like it. A lot of people don't know. There are pros to it though. The main advantage of the string inverter is that you only need one of them to convert the DC electricity coming from your solar array to AC power. If anything is going to fail on your solar system, it's typically the inverter, making the troubleshooting relatively easy when things do go wrong, because they go wrong from time to time. So we need to go out there and fix stuff. The cost of a single string inverter on solar panel installation is cheaper than installing microinverters, which we'll talk about next. Less labor hours are required, and string inverters are more affordable than microinverters. Lower probability of a wiring mishap is also huge. Because we're not converting the power at the panel, we only have to run it down to convert at the inverter itself, which means that there's less connections between the solar panels and the string inverter. Therefore, there's a reduced chance that a string inverter setup will be improperly cabled compared to a microinverter system. The cons are compliance with rapid shutdown requirements. If you live in an area which adheres to regulations for rapidly shutting down your system, which is pretty much every territory now that we're servicing, it is all the territories that we're servicing, additional labor and wiring will need to be completed on your system, so your system is within compliance. A rapid shutdown box will need to be installed near electrical service entrance, and control wires will be routed between the string inverter and electrical panel. Since there's electricity flowing from your panel and within the string inverter itself, the inverter has to be disconnected at both of these 2 points of places, okay? Since the cost of adding rapid shutdown requirements to your solar energy system is not negligible, it's important to check with your local codes and ask your installer which type of inverter system maybe will make more sense to you. And we'll answer that question at the end of this module. Efficiency in the partial shaded. So we already talked about this. Since string inverters require solar panels to be wired in series, if one of the panels' outputs is affected, the entire series of the solar panels is affected in equal measure. This is because a major issue is part of the solar panels in the series will shade for part of the day. So the problem is, just like we talked about, if a leaf lands on it, if a bird lands on it, if we had to install it close to a chimney, that entire array is now being affected by that little bit of shade. If a panel goes out, that entire array is out. They are more difficult for system expansions. To get optimal performance out of a string inverter, it needs to be working at near peak capacity. So if you want to increase the system size of your solar array at some point down the road, those panels will need to be routed to a separate string inverter, adding an additional complexity and cost. So if we do an add-on system, we're adding a different inverter. We're adding a second inverter. It just happens pretty much every single time. Shorter lifespan. String inverters are warranted to last between 8 and 12 years, whereas microinverters have a 25-year warranty. Panel level insight is not possible string inverter systems, since there's no components affixed to the back of each panel to do the job. While aggregated solar production is viewable, you won't be able to see if the individual panel performance problems, which could be caused by a crack, defects, or debris. So overall, you can see what your system in a whole is producing, but you don't know if it's a panel problem, if it's a single panel problem, or if it's the entire array, or if it's the inverter. You have no idea what's causing the decrease in power from your monitoring. You can still monitor it though. Microinverters are a little bit different. Microinverters perform the same basic function as string inverters, except they're installed underneath each solar panel on your roof. Each of these microinverters is about the size of an internet router. The big difference between the microinverters and the string inverters is a solar panel installation with microinverters will typically have the same number of microinverters as there are solar panels. So think about this for a second. We put a little thing about the size of your router that you have sitting on your desk right behind the panel. That's going to go ahead and convert the energy right there at the panel. Each panel now works independently. They do not work in a series. They don't work in a string. So if one panel gets shaded, what happens? Does the rest of the system get affected?
It's just
No.
that panel.
Just that panel. Here's a video by Enphase.
Solar panels may get the glory, but it's the inverter that does all the work in a solar PV system. Tucked beneath each solar panel, microinverters are responsible for converting the direct current produced by your solar panels into alternating current your home can use. With such an important role in safety, efficiency, and reliability, it's no wonder homeowners insist on using Enphase microinverters. Enphase is the world's leading supplier of solar microinverters with 940,000 Enphase systems deployed to more than 110 countries. The newest advancement in inverter technology, the Enphase IQ7 microinverter, is a powerhouse. It is available in multiple configurations, engineered to meet the needs of residential and commercial systems. Don't let the lighter and more discreet form factor fool you. With the IQ7 microinverter series, you get consistent high-power production, even when panels are shaded or soiled. That's not all. The Enphase microinverter burst mode helps produce energy even at sunrise and sunset. Now that's powerful. The IQ7 microinverter is proven safe and reliable thanks to more than 1 million hours of testing and an all-AC design that eliminates dangerous high-voltage DC on your roof. And in the event the grid fails or spikes, the IQ7 microinverter allows for rapid shutdown to prevent your solar PV system from energizing the grid and risking the safety of others. The advanced performance found in an Enphase IQ7 microinverter can even help with aesthetics. By producing more power, you can choose to install less panels, which can provide a more discreet rooftop installation. It is also easier for your solar installer to install and maintain. Are you looking for a complete home energy solution, including battery storage? That's not a problem with the Enphase IQ7 microinverter. The modular and flexible architecture of the Enphase IQ7 microinverter has been designed to support system expansion and storage solutions available today and in the future. Choosing the best inverter technology is one of the most critical decisions to make when going solar. By choosing Enphase, you be assured that you've made the right choice.
So the pros of the microinverter system. New electrical codes require rapid solar system shutdowns so first responders and firefighters are safe from high voltage when they need to be on rooftops or servicing power lines. Microinverters comply with these rapid shutdown requirements and have the capacity embedded in each module themselves. More electricity. The core advantage of using microinverters is that theoretically you can yield more solar electricity. The reason for this is that there are slight differences in currents between solar panels. And that's what we talked about with the flow, right? When solar panels are in a string, the current is reduced to the least producing panel in the string. Suitable for challenging installation conditions. If your solar system is facing multiple angles or azimuths, right? The panels are facing south, some east, some west, and then the microinverters are the way to go. Or if you have shading issues from trees, large chimneys, again, microinverters would be best. In these situations, the solar panels will be producing different amounts of electricity at different times of the day, but microinverters will ensure you harvest all of the energy, while with standard inverter, you will lose some of its production. Lifespan and warranties. Microinverters typically have 25-year warranties, while standard inverters typically have 8 to 12-year warranties. The reliability of microinverters was in question several years ago, big time, because they were being replaced all the time. They were constantly failing. It was bad. The technology has caught up with the industry, and the long warranties of the microinverters show the confidence the manufacturers have in their products now. Panel level monitoring. Microinverters and the add-on optimizers have the ability to track the production of each individual panel, while with the standard inverter, you can only track the production of the whole system. So does that make sense to everybody? You can actually see exactly what each panel's doing at any given point of the day,
Individually.
individually.
Yeah.
System expansion is an ease, super easy. Okay. If you want to expand your system in the future, microinverters simply add one at a time. Every time you put a panel, you just put a microinverter right on the back of it. Okay. Put that back up for a second.
Okay, I have a question there. So is that common as far as adding panels, or what would necessarily be the prime reason for adding panels?
So it's just like I talk to my customers all the time. If they have a question about whether or not they're going to be adding something down the road, like a pool, and it's like, well, I might add one of those. Well, we can't exactly take panels off, but we can always add panels back on, right? So we can put additional. There's also more and more customers who are coming up with issues with old installations where they were not offset correctly. They did add stuff they didn't plan on. They want additional panels on their roofs. So we can do an add-on system to an existing system as long as it's not a lease.
Okay.
Does that answer the question?
Yes. So that would typically be like if they were going to be some kind of, like if they were adding on to their home or a pool, something that's going to be using more electricity, basically.
Yeah.
Okay.
Anybody else? No? Okay, cool. The main disadvantage is that microinverters price is crazy. They're typically $1,000 or more expensive than a string inverter on a standard 5 kilowatt residential solar installation. Maintenance of your microinverters, if it were to fail, not only would be detecting which one of them failed would be a challenge, but once you did, servicing and replacing the component is not easy as plopping off a new string inverter on the side of the house and putting a new one back on. Your solar installer would need to get up on the roof again, work on the racking system, unbolt the solar modules, and replace the microinverter to reestablish the AC conversion capability. The amount of hardware on your roof is ridiculous. So now you're adding more electrical components, more metal components, and there's a lot more expensive metal up there because of what the purpose is to convert the power at the panel. Microinverters do act as miniature lightning rods. So if you're in a storm-prone area and you have a historical wood structure with shake roofing materials, you don't want to install the system on there. Okay. They're called miniature lightning rods for a reason. Power optimizers are the last kind that we're going to talk about. I'm going to go through it briefly, and I'm going to let SolarEdge explain it because they do it a lot better than I do and that I ever could. And you guys will understand why they are considered everybody's favorite inverter. So microinverters convert DC energy to AC energy right at the panel site, while power optimizers are also located behind the panel or behind the solar panel. They do not convert the electricity on their own. Instead, optimizers condition the DC energy and send it to a central inverter that finishes the conversion process. A microinverter gives you much more flexibility with designing your system. You can build your array in a partial shaded area or split strings across usable space of your roof. Optimizers ensure you get the most production out of each panel in your system, and you can do the same functions. So we're not getting all the pros from each one of the systems with none of those cons. Here is a video from SolarEdge that will explain it for you guys.
A photovoltaic system consists of PV panels, which produce DC power when exposed to sunlight, and an inverter, which inverts the DC power into AC power that is fed into the utility grid. 3 different inverter topologies are currently used in PV systems: a traditional string inverter system, a microinverter system, and the SolarEdge solution. The traditional string inverter topology, which is still used in the vast majority of all installations, has a number of significant drawbacks. In traditional systems, panels are wired in a series as a string. Since each panel has a unique power production profile, which is a function of differences in manufacturing variances, installation parameters, and shading patterns, the entire system's output is limited. The traditional system design requires all strings to be at the same length, using the same type of panels, and to be positioned at the same angle towards the sun. Real-life installation constraints result in either wasted roof space or unnecessary duplication of system components. The DC cables which connect the panels to a string carry high voltage as long as the sun is shining. The traditional inverter cannot shut down the panel's DC voltage and therefore poses serious risks to installers and firefighters. A traditional system cannot track power output, temperature, or any other parameter of a single panel. This makes it impossible to identify specific panel-level problems remotely. In the 90s, another inverter topology was introduced, the microinverter. This topology takes the functionality of the traditional string inverter and scales it down to fit a single panel. By controlling each panel individually, microinverters are able to solve certain challenges of the traditional system. However, microinverters have their own inherent drawbacks. This topology requires each panel to have its own microinverter with full inverter functionality. Therefore, it has significantly higher upfront costs relative to traditional inverter topology. When we started to develop the SolarEdge solution, we defined 3 goals: to optimize power generation of each panel individually, to use the same installation methods and components used to install traditional inverter systems, and to compete with the cost of such systems. Eventually, we developed a topology that meets all of these goals. The SolarEdge DC optimized inverter topology combines the best of both worlds. Our solution splits the traditional inverter functionality into 2 products, the Power Optimizer and a simplified inverter. The Power Optimizers are located on each panel, turning the panels into intelligent panels. These Power Optimizers provide panel-level tracking and real-time adjustments of current and voltage to the optimal working point of each individual panel. The simplified inverter is installed similarly to a traditional inverter, but it is only responsible for DC-AC inversion and grid connection. Our solution includes 2 additional features: a panel-level cloud-based monitoring platform, which is accessible from any computer or handheld device, and an enhanced safety mechanism. When installers install the SolarEdge solution, they use the same cables, connectors, and methods as used in traditional systems, and are able to install more panels, to combine long strings with short strings, and to install panels on different facets of the roof. The SolarEdge cloud-based monitoring platform provides full data at the panel, string, inverter, and system level. This allows for immediate fault detection, real-time alerts, and comprehensive analysis. These important features reduce operation and maintenance costs. In addition, we have incorporated panel-level safety mechanisms to protect installers, electricians, and firefighters. With the SolarEdge solution, whenever AC power is off, the string's DC high voltage is automatically reduced to a safe voltage. This solution meets new safety regulations in all significant PV markets around the world, as well as the 2014 National Electric Code in the US.
And that helps sum everything up, guys?
Yeah, I get that.
Awesome. So, guys, that's literally it right there. Like, do you guys see why that's everybody's favorite inverter, why we use it as a standard?
Definitely.
Yeah, we get the best of both worlds. All right. We don't have miniature lightning rods on the roof. We don't have panels that have to work together. We can install them on different azimuths. We can make different types of arrays. We can do everything with the SolarEdge. And standard warranties on those are a lot like string inverters, and they're 10 years. However, we give a 25-year warranty on the SolarEdge inverter.
25.
A photo
Questions? Cool. Let's move on. System sizing. I love this one. Again, this is something that you are not even going to be tested on. Okay. This is gone over so you guys have a basic understanding of what we're doing on the back end and why we came up with the system that we did at a high level. There's all those other components that come into play. So if we were just doing, this is what most companies do. So it gives you an idea like, oh, we're just going to go ahead and make this estimate because we do have an algorithm to be able to size the system. There's all those other functions that go into place, the tilt, the azimuth, the type of inverter that we're using, the time of year that they use the most power. We put all these factors into place. We're also known as a new construction specialists because we can project out their usage based off of knowing how many people are inside the home, what degree temperature they like to set the thermostat to, the square footage of the home, single story, 2-story, the type of appliances that they have, how often they're going to be using that stuff. And we can project out to 99% what system size they need, and we get it right 99% of the time. So it's great. And if not, we can always add more to the system later. So check this out. To figure it out, we need to get the system size for the solar system. So we take your kilowatt energy requirement and divide that by your peak sun hours to get your kilowatt output. Then we divide the kilowatt output by your panel's efficiency to get the estimated number of panels that you need for your solar system. Okay, so take a look right here on this customer's usage. You can see in the summer, this is where they use the most. So here, this is good to know because okay, cool. We need to account for these, but here's where they're using the absolute most power. So we need to make sure that the tilt and the azimuth and all these other stuff, the shadings and all that other stuff aren't affected as much here when they need the equipment the most. Okay, so here's a basic algorithm on what we use. So on the solar overview, it looks just like this. Here's the formula. Annual kilowatt hours divided by the peak sunlight hours equals the system size. So if we have a system that needs 14,500 kilowatt hours, and let's say we're in Arizona, we have our azimuth and all this other stuff, it's 1.75 peak sun or 1.7 peak sun hours is what we're going to be dividing by, which gives us 8,529 watt system. If we want to determine the wattage or the kilowatts of that, we just divide that by 1,000. So let's go back to I think 4th or 5th grade when we learned this, and you guys are going to have to relearn it. So if we are dividing or multiplying by 1,000, all we're doing is moving a decimal 3 places. So whenever we're dividing or multiplying with a 0 at the end, right, with 10, 100, 1,000, we're moving it the number of zeros that we have at the end, right? So if we want to figure out what the kilowatt is, we divide by 1,000, which gives us an 8.529 kilowatt system is what we need for this customer. So the formula to determine the number of panels is we take this system size of 8,529 watts and divide that by the panel wattage. So let's say that we're using a panel that's 350 watts. That would give us 24.116 panels. Okay. Now, can we cut a panel into pieces and place it on the roof?
No.
No. All right. 100% correct. We cannot do that.
So you just add an additional panel?
We add the additional panel. We round up. Perfect answer. You answered right before I asked it. Perfect. Good thought process. Great minds. This is going to be our true system size because we have to determine the offset now. And I'll show you guys the offset here in a minute. So it looks like this. If we have 25 panels instead of 24, we multiply that by 350 watts. The customer's system size is actually going to be 8.75 kilowatts or 8,750 watts. Okay. So the system size times the peak sunlight hours equals produced kilowatt hours divided by required kilowatt hours equals offset. Do I want you guys to worry about all this math and algebra and calculus and all the stuff that we're doing here?
No.
Oh.
No, you guys are never going to do this. Why am I teaching you? So that you're confident in what we did on our back end. Okay. You guys know the basic function about what we're doing. This is literally the basic function. So 8.75 or 8,750 times the peak sunlight hours of 1.7 will give you 14,875 kilowatt hours to be produced, which means that if we divide that by the kilowatt hours that they use over the last 12 months of 14,500, we're going to be producing 2% more power than they've used over the last 12 months to give them a little bit of wiggle room. So if they want to drop the temperature of the thermostat a couple degrees, they can. If they get a cloudy month in monsoon season, they're covered. Does that make sense? So, let me go over that here in a second. Let me see where we're at. I'm gonna come back to that one because I want to go through the actual proposal with you guys really quickly. So I'm gonna show you guys a real proposal from a real customer today. And show you guys the breakers and we'll talk about that. So, oops. Okay. Go back to screen share. You guys see my screen? It's blank right now. It should be loading.
Yep.
Okay. Okay, so here's Amanda's proposal. So if we're going to go through this thing with her, we're going to look at a couple factors. So $245 a month is what this customer is using in electricity on average. Okay. There's an annual escalator on utilities of 4% a year nationwide. We're going to go into more detail about this on Thursday. So I'm just going to give you guys a brief rundown. So what this means is that there's a cost of inflation. So think about what you were paying for gas prices back in 2020. If you would have locked in your gas price at $2 a gallon, how happy would you be today?
Yeah, not too happy.
Pretty happy, right? So you can't, so this is the goal with solar, is we can lock in this rate and never have to pay more than that. You'd be pretty happy because if you use the exact same amount of electricity that you use over the last 12 months, you're gonna be paying for the same bill, $653 instead of $245. So the property value increase on this house, oh, I don't know why it's doing that. It was $39,000 property value increase.
Mm.
They need a 12.8 kilowatt system. Their system is going to produce 20,026 kilowatt hours that first year for production. And they're going to be using the Hanwha Q-Cell Peak Duo Black MLG10 400, 32 of them. What that means, it's a monocrystalline panel. The ML, we are a monocrystalline panel. Okay. This is a tier 1 panel. This is the best equipment that you can get. We offer it as a standard. There's no upgrade on it. We're also using the Solar Edge. So I would likely change this from the 7,600 plus the 3,000 to just the 10,000 inverter, and we'll be good to go. But this is what it'll look like. So you guys will usually have a picture of the customer's roof and the panels will be drawn on there just like this. Okay. Because this is a new build, it's brand new construction. It's actually only about a month and a half old. We did a lot of projections out with this customers, but I sent over what the roof lines are like and they built it out that looked like this. Okay. So that kind of answered your question earlier about what we know what the azimuths are, right?
Mm-hmm.
You can see it directly on the roof. Okay, so this is north, south, east, and west. We can show them the historical averages in their area. This is specific to their area and what they're like. So for the same usage, somebody was only paying like $25 back in 1970. Now they're paying $200. Here is where they are consuming energy. Here is where they're producing energy. So all this is bill credit. So if they need to overuse, or if they overuse here, which we're projecting that they will, this is where that bill credit will offset any additional usage. We're going to be producing 8% more power. We can show the customer what their bills are going to be like in the next 25 years. So we got 5 years, 10 years, 25 or 15 years, 20 years, and 25 years. Okay. I can grab their system size and change it. It's not going to let me change it here. So give me 2 seconds. Let me go and change it in the other one. So you guys can see it. It's not going to let me change it on that part of it. Solo, and you guys will have access and to go solo and all that other good stuff tomorrow. Update, view. You guys see my browser okay?
Yeah, I can.
Cool. So same proposal, okay? $39,040. CO2 offset, equivalent numbers of trees planted. 12.8 kilowatt system. You drop down to the finance. So we have something really cool. So if we do a good leap, and let's say we do a 20-year 1.49% APR, okay? The customer's bills will look like this. The first 18 payments are only going to be $194. If they reinvest that federal tax credit and the state credit from Arizona, it's only going to be $189. Now, we also have a 25-year version of that, which is 1.49. This is going to again lower that monthly payment because they go a longer term, 167 and 163. That's almost $100 in savings right there. Pretty great, right? We got something even cooler. So on Good Leap, and your manager will determine this one. So your manager makes all these adjustments for you guys at first, and you guys will get authority to change that stuff down the road. 25-year 1.98 flex pay. Interest only payments of $90 for the first 18 months. Once they reinvest, they're only at 174 after that. So they can decrease their monthly by $160 a month for the first 18 months, which gives them time to qualify for the tax credits, reinvest it back into their system so that they can keep their low payment, and then they're at 174. Okay. They decide to keep the tax credit, pay off a credit card, buy a car, go on vacation, $237. It's about $5 for every 1,000. So even if they decide to keep that, if they locked in their price, how happy are they going to be in 5 years, 10 years, 15 years, 20 years, 25 years, right? If they don't, and they decide to reinvest it, they're going to be pretty happy. Okay. Everybody see why everybody's telling us this is a no-brainer?
Yes, sir.
Cool. Same customer. Okay. So now let's talk about breakers. Well, that just crashed on me. Let's talk about the breakers. Okay. So there's a couple pictures we need to take, which are going to be important when you guys get this. We're going to go more over that on Thursday. But you guys need to understand a couple of things. Okay. So a lot of the new homes that are being built, they're called solar ready. What that means is they have a 200 amp main breaker and that they have up to 200 amp total, and they have available slots. There's something called an MPU, which is a main panel upgrade. Again, we're going to go over this specifically on Thursday. And we would need to upgrade the customer's main panel so that we can actually install the solar. That's an additional cost to the customer. It's not something that we cover. So the main breaker amperage is 120% rule. Okay, so it's so if you have a 100 amp breaker, you got 20 amps of solar. You have a 150 amp breaker, you have 30 amps of solar. 200 amp, 40 amps of solar, 225 amp, 45 amps of solar, and 400. You're not going to really see that on residential stuff unless they're running a shop in their back or something like that. 80 amps of solar. So this is basically what it boils down to. So when we're asking for pictures of the utility box, this is what we're looking for the back end. You guys don't determine what if it's going to need a upgrade or not. We'll determine that on the back end. The site surveyor will also determine that when they go out, because they're going to double check the pictures, and that what we determined was going to be best. Okay. But these are the things that we're looking for here. So these are some of the good panel brands, and you guys are going to see these out here. The Murray's, the Cutler Hammer, the GE, Square D. you see Federal Pacific or Federal Pacific is actually one of the worst ones. So just keep that in mind when you guys see this stuff. If anybody asks, you're not an electrician, don't even worry about it. We'll take care of it at the site survey. Okay. Brian, you have time to go over this real quick? Because I know you wanted to talk more about this yourself.
Yeah, sorry, I'm stuck with kid bedtime routine. I think all of us know the drill there. But yeah, the main thing that we were looking at is we're going to get you all a guide on exactly what pictures to take when you're at the house. Here's a couple examples of them. But getting those over to us, we'll be able to determine if anything else is needed. But the main focus is to have a lot of information for the install crew and the permitting folks, so that way the jobs move quicker. So, having good pictures up front just shaves weeks off the time frame. So that's the big focus. But we'll get you what you need.
Awesome. And we're going to go back over this on Thursday. All right. So here's different types of mounting. Okay. So all mounts are fully flushed and sealed. So if you guys take a look, this is an actual mount. Those are mounts that are all put right there. So we want to make sure that they're completely flushed and they're drilled into the actual truss itself so that it can support wind loads and other problems like that. So the unsupported roofing is a clay roof. There are different types of clay. So let us determine that during the site survey, whether or not we'll be able to install on it or not. Okay, go ahead and sign the deal. We'll take care of the rest. If it can't, then we have to disqualify it. But there's other things that we can do to make sure that we can get it installed. There are plenty of clay roofs that we have installed on, but general rule, they're super delicate. We can't reinstall them. There's a lot, there could be more issues that go with them, and they're extremely expensive to replace and repair. So when it comes to reselling your house, why do homeowners go solar still? Well, property value increase is huge. Homes would purchase solar sell up to 20% faster. It's a great value proposition and lists better on the MLS. So if anybody's ever sold their home before or bought a home, you understand what realtors are looking for. It populates a lot higher and it populates more often. Affordability objection is overcome because now somebody who wants to move into that house but is worried about the electric bill, boom, has solar. You don't have to worry about it anymore. And it creates urgency because the realtor knows to tell the buyer, like, hey, guess what? We have, it's going to sell faster. So you guys might want to put in an offer now. So according to a recent Zillow report, homes with solar panels sell on average of 4.1% more than comparable homes without solar across the United States. A study conducted by the Lawrence Livermore Berkeley Lab also found that homes with solar panels tend to sell faster than those without. A consumer guide from the U.S. Department of Energy states that a solar electricity system can raise your home's property value by $20 for every $1 in utility savings per year. That's a huge number when you go to increase the property value of your house, and most homeowners want to increase the property value before they sell it. So another important definition, so you guys write this down because we don't hide from it. 3-day right of rescission. The right of rescission refers to the right to the consumer to cancel certain types of loans. We fall under these. So it falls under like refinancing your mortgage. And if you want to rescind and cancel your mortgage contract, the 3-day clock does not start until the night of, okay? It also doesn't work on non-business days. So it's business days is what matters. So you sign the contract. Once you sign the contract, it starts at that day, and then you have 3 days from that point. The right of rescission is a legal right that allows consumers to cancel certain types of home loans, such as refinance, home equity loans, home equity line of credit, a HELOC, and even some reverse mortgages. It gives the 3 days to rescind an agreement and get your money back. It's very commonly used in the real estate industry because of the type of installation that we're doing, and it refers to like that we do have like PACE programs and stuff like that do allow for it to be rolled into mortgages. We fall into the 3-day right of rescission. People can and will be able to cancel their contracts. Give me 1 second, I'll be right back. Sorry about that. Timer went off for the kids' dinner. I had to go turn off the oven. Cool. So here's your solar recap, guys. This is available to your document in your document library. Go ahead and write as much of this down. Kilowatt. So when you see kW, that equals kilowatt. Kilowatt is a watt times 1,000. Okay.
Will this be on the test?
Some of these will be on the test. So write these down. I'm gonna leave it up for a little bit so you guys can write as many of them down as you can. You will have access to download this exact slide. So if you don't write it down, it's okay. Tomorrow night, you have access to download all this stuff. Okay. And I'm going to send out these exact definitions. Don't even worry about writing it down. I'm going to just send it out.
And I just kind of screenshot it too. It makes it kind of like a cheat sheet as well.
Yeah, screenshot. Do the write on slides, right? Kilowatt hour is kWh. Residential solar system is also known as a PV system. Typical solar panel warranties are 25 years. Typical inverter warranties are 10 years. Typical workmanships are 10 to 20 years. We offer a 25-year at Titan. Inverter warranty, we offer a 25-year on the Solar Edge. Typical battery warranty is 10 years. That doesn't change. Lifespan of equipment is between 25 and 30 years on polycrystalline, 25 to 40 years on monocrystalline. Okay, so we're looking at average lifespan, 30 to 40 years is what we're looking at. Okay. Typical leases. So we don't like leases are 1.9 to 3.9% annual escalators. So if we think back to what the utility charges on an annual escalator increase, they're at about 4%. So is there much of a difference when going with the lease? Nope. You end up paying the same amount, if not more, sometimes with the lease. Solar finance terms are 5 to 25 years, all the way down to 0.99 to 4.99% are the average APRs. The inverter converts direct current or DC to alternating current, AC, or sun power to house power. Power generated is sold back to the utility company's bill credit. Bill credit expires. This does not roll over from year to year, only month to month. If there's a battery backup, the battery is used before the utility power is needed. We're going to talk about batteries here in a minute. Utility sells the power to homes as needed only with demand time of use. So if you overuse, the utility is going to sell you only power that you only use as time of use. And this will make more sense on Thursday as well. The position, including angle of the panels, directly affect production. Here's another cheat sheet. Oh, did I hide it by accident? I did. My bad, guys. Got two versions of it for you guys. So watt. A watt is a unit of electrical measurement. A kilowatt is watt times 1,000. Kilowatt hour, kilowatt. PPK, so when you guys see PPK is a price per kilowatt. PPW is price per watt. PV system, photovoltaic system, is a solar system. Tilt, the degree the panels are angled, 20 degrees is a standard. Okay, so this is what we're using for most areas in most of our territories, and it works on like 90% of our roofs. Okay. Pitch, the customer's roof, also the slope. 412 is a standard roof, 112 is considered a flat roof. Azimuth, the direction the panels are facing. Due south is best for solar in most territories. Cool. Offset, the amount of solar replacing last year's electric usage. System loss, we didn't go over degradation or system loss very much, but it's because it's very simple. It's the amount of production the system will lose over time. And degradation is the rate the system will lose production. And the example is about 6% a year, or 0.6% a year, so 0.5% a year. Okay, now think about your phones. When you bought your original phone, is it as bright as it was on the day you bought it? Does the battery last as long as it did the day you bought it? Everything degrades over time. Solar panels are no different, about 0.5% a year on average. By the time the 25-year term is up, they're usually between 75 to 85% total production is what they were originally at. Okay, as an aggregated. Open mount versus fixed mount. So we talked about that open mount on flat roof systems where we have to open it up and give 3 feet spacing in between. Choose on flat roofs. And a fixed mount system is just affixed straight to the roof. Module is another name for panels. Monocrystalline and polycrystalline are the types of panels. We went over that in depth. A string inverter, it runs in series. If one of the panels stops working, the array stops working completely. Then optimized and independent systems, panels work independently. They do not affect each other. I'm going to go ahead and leave this up just in case anybody needs to take a screenshot or write anything down. What questions do you guys have about any of the stuff we've covered so far?
Just real quick about the
Pretty thorough.
Thank you.
the I'm sorry, I'm blanking now.
You're good. It's a lot of info, man. You're going to blank.
Yeah.
You guys are going to feel overwhelmed tonight. I promise you. It's okay.
I felt better. I felt definitely overwhelmed in the beginning, but I feel 100% better now.
They all kind of tie together, right? All the definitions
Yeah,
start to tie
absolutely.
together. They help each other make sense. And then once you guys see it tied to a proposal, you're like, oh, I do know this stuff. So on Thursday, you're going to be like, yeah, this is actually, it's not that hard. And you can figure out a way to explain it in 25 minutes to a customer. Because we talk to them like they're 5. Okay. We don't talk down to them like, oh, hey, buddy. No, not like that. Okay.
So I just remembered the question. As far as investing their tax credit back into the system, what do you mean by that? That's them just paying off their loan or whatever with it, or?
Yeah, they put it as a down payment. So we're going to go over reamortization periods and ITC on Thursday. But essentially the finance company assumes that they're going to get their tax credit back and put it as a down payment. So they just give them payments as if they put it down during that period of time. So they would be financing the lower amount and not the higher amount. So you'll have exact examples of that on Thursday. And you guys, we're going to go over those definitions separately on Thursday.
All right. Thank you.
You're welcome. Any other questions? Cool. Everybody's favorite, energy storage. This is gonna be the last thing we're gonna cover today, guys. I'm gonna let you go. I want to try to get you guys out of here just a little bit early because I know it's getting late. I'll let you guys go eat your dinners. Okay. So energy storage, biggest question you're gonna get, and we talked about this a little bit earlier. Solar will power my house when the sun goes out, right? Absolutely not. Okay. If you have a solar only system, your system will not, under any circumstance, provide power to the house. Okay, it gets cut off. It has a rapid shutdown. So typically it works like this. ESS storage, it stores energy during the day, and then it discharges the power when your panels aren't producing power to avoid time of use charges from the utility company when the grid is down. So really simple. It works just like this. As soon as night comes down, it's going to start sending up power to the house, right? It's going to replace the power that was being produced by your panels and from the utility company, so you can island yourself from the utility company. The other thing is, you guys have all heard the time of use peak hours to not wash your laundry or run large loads during that period of time. And they usually give you between like 4 and 7 and stuff like that, right? That's because when everybody starts using the most power. So this helps do it because now you can actually use your battery to replace that, so you don't have those time of use, because that's when the sun is actually going down as well. So batteries have multiple purposes, and Tesla Powerwall is our favorite for that reason. So what is a solar battery? A solar battery is a device that can add your solar power system to store the excess electricity generated by your solar panels. It never gets sent back to the grid unless your battery's full and you're not using power, right? You can use that stored energy as power to power your home at times that your solar panels don't generate enough electricity, including nights, cloudy days, and during power outages. The point of a solar battery is to help you use the solar energy you're creating. If you don't have battery storage, any excess electricity from the solar power goes to the grid, which means you're generating power and providing it to other people without taking full advantage of electricity your panels create first. Okay, so you're actually powering your neighbor's home, but you're only getting 7.9 cents per kilowatt hour, and the utility company is charging them $7.50 or $8.25 or $8.50 on top of the normal production charges, and they're making the profit from you generating power. This is the beauty about getting batteries. Now, we have a conversation with the customer, and I'm going to go over that with you here momentarily. So the most popular battery is that lithium battery. So if we take a look, we have the negative charge and we have the positive charge. So right here is where the power was used, and it all gets stored right there. But because it's a rechargeable battery, the electrons flow back, which allow it to be able to charge back up so that you can use it again. So does that make sense now from the original voltage conversation that we were having about batteries with positive and negative nodes? Cool.
Yes.
Cool. So they're the most common batteries are lithium ion. They're used in cell phones and tablets, computers, electrical devices. Anything you guys are talking to me on right now, you're using a lithium ion battery. Okay. So when comparing batteries, there's different types: lead acid batteries and lithium batteries with the flash batteries, which charge faster. All that other stuff. We see like phones are charging like in 15 minutes now. Tesla cars are charging in 45 minutes to run 300 hours and all this other stuff, right? So lead acid batteries don't have that capability. They're not currently being used as a standard with 99% of solar companies, but some smaller companies, that's all they have access to and all they can afford. So you will sometimes have to compare against them. It's just an older technology is a basic way to understand it. They don't have the same depth of charge. So when it comes to solar batteries, there are two common types: lithium ion and lead acid. Solar panel companies prefer lithium ion batteries because they can store more energy. They hold that energy longer than other batteries and have a higher depth of charge. Also known as DOD, depth of charge is the percentage to which the battery can be used related to the total capacity. For example, if the battery has a DOD of 99%, it can safely use up to 95% of its battery capacity before it needs to be charged again, so it doesn't break. So that's why when you see your phone turn off, you can still see that little power up icon on there. There's still a minimal amount of battery that's in there, because if it gets down to zero, the DOD, if it gets below the DOD, guess what's going to end up happening to that battery? Is it going to be usable? Can it be recharged?
It's just dead.
It's completely dead, right? That's what happens over time. That's what happens with lead acid batteries. So think of a lead acid battery that you have in your car. That's a lead acid battery. The depth of charge isn't as great, which is why you need an alternator to be able to continually keep that battery charged while you're driving it and while you're using it. Because if you keep your lights on, the probability of being able to recharge that battery is actually, it's a toss-up, right? You could have killed the cell, which means that it went below the depth of charge, because they're not as powerful as a battery, and they're not as reliable of a battery as a lithium ions. Okay. So there's two types of coupling when we couple these things. So there's DC and there's AC coupling. We're using AC coupling typically. So unlike DC coupled storage, it only stores solar from the solar panels. One of the biggest advantages of AC coupled storage is that you can store power from both the solar panels and from the grid. This means that even if your solar panels aren't generating enough electricity to fully charge a battery, you can still fill the battery with electricity from the grid to provide you with the backup power, or take advantage of the electricity rate bridge. So arbitrage. So what happens is that during that, when it's not peak time of use, and most of these batteries, they have a component that's going to say, oh, now's the best time to charge this battery up. And they'll actually pull power from the grid so that you have a full battery in case of a backup. So if your system size isn't fully like huge and you need to draw that, that's fine. On a cloudy day, you need to draw it, it's fine. You're still going to offset enough that you typically can still make sure that you're not getting crazy bills. It's usually easier to upgrade your existing solar system with an AC coupled battery, because it's just it can just be added to the top of the existing solar system design instead of needing to be integrated into it. It makes AC coupled battery storage the most popular option for retrofit installation. So we can add AC coupled systems to existing solar panels. We can't add DC coupled. We don't typically use DC coupled. It's very difficult to come across DC coupled. But the reason why you guys are learning this is because it may come up from a customer. They say, hey, are you using DC or AC? We're using AC coupled systems. So yes, you can charge your battery from the grid. That is the answer that you're getting from this. Do you want to? No, we want the panels to do it, right?
Okay, now is that an additional cost or is that something
Batteries are always an additional cost. Yes.
that's gonna come with it?
Yeah, they're always additional cost. So I will
that's-
go over the cost of the batteries on Thursday.
Okay, perfect.
Yeah, so there's two types of systems. There's solar only and solar and storage. So the process is slightly different with AC coupled systems. Sunlight hits the solar panels and then the energy is converted to DC electricity. The energy, the electricity enters the inverter and converted to AC electricity that the home can use. Excess power flows through the inverter to change back to DC energy to store it at the battery for later. So the battery stores DC power. So if the home needs power from the battery, it sends it back through the inverter so that you're getting AC energy again, AC electricity, okay? DC couple, just really quickly, all it does, it goes straight from the, it's just like microinverter type systems, right? They're not popular anymore because they're not practical. Okay, so DC coupling, it goes directly to the charge controller before it sends it to the out, and then sends the output to the actual inverter with the battery connections. Okay, so it's a very complicated system. It's not used anymore. Okay, there's a lot of other components, if you guys can see, and they would be able to store, throw any power back to the grid, and you cannot charge it back from the grid because you need the charge controller in order to do it. Okay. So I'm not going to go too much into depth with it because we don't need to worry about it. So here's an example of what we're talking about. So the battery is being charged. The battery is going to know it needs to charge. Let's charge the Tesla and then let's power the home as well, right? When the grid goes down, the battery's still taking care of that. Now, not all batteries, one battery isn't going to do everything. So depending on what the customer wants to do, we may need to have multiple batteries. If they just want a simple battery to keep backup for their lights and for the fridge, yeah, one battery should be fine. If they wanted to do everything as the grid does, they're going to need multiple batteries in order to do it because of the depth of charge and the kilowatt hour storage that the battery can provide. Okay, so typical is 13.8 kilowatt hours that a single battery can store. It doesn't have any type of super capacitor or anything like that that would be able to deliver a huge amp load to be able to turn on something like your AC. If you want to have your AC and a standard backup, you're still going to need 2 to 3 batteries. So if a customer wants batteries, we need to have a whole conversation separate, which we'll learn more about on Thursday, in order to be able to have that conversation with them. Okay. It's like, look, we need to know what you want to power, how long you want to power it, and exactly what you're wanting to do. We can always add more batteries onto the system later because the cost of batteries can be expensive. They start out between $12,500 and $15,000, and then each additional battery can be about $10,000 each after that. They are not cheap. So if the customer is just trying to save money, yes, a battery is an idea, but that doesn't mean it's practical for them. We still have the conversation so they know. They're like, yeah, I'd rather just go with the solar only. Okay, great. They're just trying to save money. Okay. So here's a cool little here's a couple things to know. So benefits of the battery: it provides electricity even after the sun goes down. When the sun goes down, the solar panels aren't generating electricity. The grid steps up to provide much needed power if you don't have battery storage. With a solar battery, you'll use more of your own solar electricity at night, giving you more energy independence and helping you keep your electric bill low. Okay. Provides relief from power outages. Since your battery can store the excess power created by your solar panels, your home will have electricity during a power outage when everybody else doesn't when it goes down. So solar only systems, your next door neighbor, they have solar only. They will not have power, but your house will. Okay. And it stores extra electricity generation. Your solar panel system can often produce more than you need, especially on sunny days when there is no one home. If you have solar energy battery storage, the extra energy will be sent to the grid if your battery is full. Okay. If you participate in the net metering program, which is now DG Export on a standard, you can earn that credit for extra generation. So it can still be bought back. So if your battery's topped off and you don't need any excess power and your system's taking care of what you need, you could still get bill credit from the utility company. It's the best of both worlds, but it can be expensive. So Powerwall does offer off-grid. There's a good way to test it when the customer first gets their battery system. And Tesla's monitoring system is amazing. Here's a video from them that explains how their off-grid system works and how to test the off-grid.
Go Off-Grid allows you to simulate a power outage by disconnecting Powerwall from the utility grid. This allows you to familiarize yourself with how your Powerwall system will perform and what in your house will be powered during a grid outage. The Tesla app monitors how long your Powerwall system remains off-grid. You can find your off-grid backup durations in the backup history screen. To help ensure stable system operation and reliable power for your home, you'll need to pair Powerwall with each phone that will operate Go Off-Grid. To pair your phone, go near any of your Powerwalls and then open the Energy site of your Tesla app. Select Settings, scroll down, select Pair Phone to Powerwall, and begin pairing. When prompted, toggle the switch on your Powerwall off, then back on. To go off-grid, go to the Energy site of your Tesla app and tap Go Off-Grid. If you haven't yet paired your phone to Powerwall, you'll be prompted here. When ready, select Go Off-Grid. You'll receive a notification when your system is off-grid. It may take a few minutes to transition. Once Powerwall is off-grid, your system will behave as if there were a power outage. If you choose to charge your vehicle while off-grid, Go Off-Grid respects your vehicle charging during power outage setting and will stop charging when Powerwall discharges below the set percentage. When your Powerwall is fully charged while using Go Off-Grid, excess solar production will have nowhere to go, so Powerwall will signal your solar inverter to turn off. To maximize solar production, use the Tesla app to reconnect to the grid before Powerwall is fully charged. Your Powerwall system will automatically reconnect to the grid when it's too low on backup energy, or if Powerwall is unable to provide enough power to support the devices or appliances in use in your home. To manually reconnect to the grid via the Tesla app, simply select Reconnect to Grid. You can review details of the event in the backup history screen. Go Off-Grid allows you to simulate a power outage by Go Off-Grid.
Okay, stop going off grid. Go to the next slide. There we go.
From the moment you wake up, you
Okay, cool. So before we get into this next one for Curb Energy, what questions you guys have for me about batteries?
So the battery can be put in along with the financing of the system, or is that totally separate?
With the financing, yes.
Are a lot of those sold? Is that a pretty common?
It's probably about only 10% of the systems that you're going to come across actually want a battery and can afford it.
Okay.
Cool. Anybody else? All right. So this next one is Curb Energy. Okay, so we love Curb Energy. We added it as a standard in all of our installations because now a customer can actually monitor their usage, not just their production. So with the Solar Edge, they can monitor their production. They know how much solar they're creating. The problem is that you guys have no idea how much electricity you're using right now by running your laptop, right? By having this conversation with me. It's not like pouring a glass of milk. You don't know how much milk you have left, right? So with Curb Energy, we actually give the customer that function at no additional cost. They can see how much power they're using, and it'll send them alerts if their production isn't meeting up with it. So it's a really, really cool program. We offer it at no additional cost to the customers. We'll go ahead and install it on every single one. Here's how it looks.
From the moment you wake up, you depend on electricity. It powers the technology all around you, making your home safer, more comfortable, and responsive to your needs. But electricity is confusing. That's why we built Curb, the whole home energy intelligence system. Isn't it time to power smarter? to take control of the very thing that connects you to your world? Say goodbye to energy bills that come a month later and don't tell you where your money went. Curb shows you exactly how much power is being used at any time.
So I really love Curb for two reasons. I love it from a budget perspective, and I also love it from an environmental perspective. This part of the app here shows me exactly where my money is going so that I can have all the data I need to make changes for next month so I can lower my utility cost and also lower my impact on the environment.
Curb is installed in your home's breaker box, where it monitors everything that uses electricity. It lets you know when things are accidentally left on and forecasts your electric bill so that there are no surprises. Curb sensors work like a brain, processing electrical data and identifying home energy trends. So you can rest easy, knowing that Curb is always on the lookout. If Curb notices something odd, you'll find out right away. And if your appliances start acting up, Curb will give you time to plan. Curb will even remind you of the little things, so that you can focus on the more important things in life. Over time, Curb will learn about your energy behavior and give you personalized tips, saving you money and making your home more efficient.
What was really the benefit was this deeper understanding. How are we using energy? Where are we using it? It all has a cost associated with it, but it was that learning experience for the engineering folks amongst us that I thought was particularly valuable. And it does end up changing your actions. It changes the way you interface with energy, and that's a good thing overall.
Curb gives you the power of information and shows you the impact that changes have right away. You can even set up alerts when you get close to your budget to help you adjust and stay on track. And to make your life easier, Curb also works with other smart home devices, allowing you to power things on and off directly from the Curb app, no matter where you are. Power your life smarter with Curb.
Cool. That's our wrap up. What have we learned? What do you guys have questions about? Let's have a conversation.
This is just a random question I had, but like where my parents are, they're on a co-op. How does that interfere with a co-op? Is that even an option?
Co-ops are fine. There's no difference. They just have to get the interconnection agreement just like everybody else. A lot of co-ops,
Okay.
like for instance, we have Trico out here. The co-op out here actually does pay the customer back at the end of the year any excess that they haven't used, any bill credit.
Okay.
Yeah.
Cool.
Everybody's brain's kind of fried after tonight.
A tad bit.
It is okay. I understand. So I just compiled the last 8.5 years of knowledge that I have in solar in your guys' brains in about 3 hours. You're welcome.
Thank you.
It's okay. You'll thank me when the checks come in.
I am below.
Tomorrow we will do a brief recap of this stuff. Once you guys unwind a little bit, this will be available on YouTube. I'm never taking it down. You guys can go back and watch as many times as you want with your guys' questions in there. Okay. Just feel free to reach out by text, even if you just want to use me as a notepad for something to me to answer tomorrow. So if you guys do come up with a question and you want it answered, just shoot me a text and I will answer it tomorrow during training for everybody else to hear. Okay. So I won't respond
Cool deal.
unless it's specific, like you're like, hey, I got somebody that wants to do an appointment, they want to do a proposal. Like that's a different type. Like I'll respond right away. If it's like, hey, what about this? I want everybody to hear that question answered. So I won't answer. I won't text you back the answer, but I will answer it in the training tomorrow. Okay.
Right.
Okay.
Cool. If everybody feels good and they're happy, feel free to start logging off when you're ready. You guys have a fantastic night. Go enjoy your dinner. Thank you for joining me. I'll see you tomorrow at 4:30 Mountain Standard.
Have a good night.
Good
Bye-bye.
night, guys.
Good night. Bye.